right, we're gonna let that chill there. Got it. Okay, so usually the stream is working by now, so I'm gonna just go ahead and start the audio while I'm still getting things set up. Maybe not, because I get distracted. It's trying to multitask, and it's like I'm trying to think about what I want to say to you, but make sure I'm doing everything I need to do. Give me just a moment. I'm almost done with this stuff. Okay, I think we got everybody. Yeah, the for some reason, like this hour just seems like it's a lot easier to be here, be present, because all of us are fresh. You know, it's early in the morning. I know that's when I think this person was here and like left or something like that, because I got them already. But yeah, like after about lunch, I've even found that it was difficult to study math, right? Or talk about it. Hi, Professor. I was marked absent on last Wednesday. Remind me at the end of class about that. We can take a look at it. Just remind me, because I take attendance like I did now. I do the same thing every time. Yeah, so usually that means you weren't here, and right now I'll be kind of, light with it. But going forward, because sometimes I do make mistakes, so I try to give you the benefit of the doubt. But I don't want that to be a common thing. Let me see screen. Okay. But yeah, we can, right now I'm being kind of light with all of that stuff. And okay, so as far as announcements go, so like with attendance, you don't really have to stress too much about the attendance. And what I mean by that is like, if you miss a day or two, it's gonna be okay. Even if it's like maybe 3 or 4, like once you hit 3, you might be marked for like being removed. But if you can just make a case, like if you make a case, say I've been coming to class, I don't know what happened, like, and I can make sure that you're in there, the attendance doesn't affect your grade directly. It only affects you if you get booted out of the course, right? And obviously we want to keep that to a minimum. We want to avoid that as best we can. But don't worry about it. It's not going to affect your grade. And just as long as you're just making it, you have some kind of case where, hey, I've been coming, here's my work, you've been like submitting your assignments on time, everything is done. I'm not going to be like, oh, you missed 3 days. I'm not going to make a big case for that, right? But just do your best. I just don't want you to worry too much about that. The main things that I want you to kind of put your focus on is getting your online assignment submitted promptly and being prepared for the exams. This section does have a lab, right? So just be sure that not only are you doing the assignments in Pearson, those are the assignments for our regular class, which is the homework, quizzes, and exams. But then there's a lab component to this section, the 9 a.m. And so to access that you contact Dr. Lamar, which is one of my colleagues, and the link is on our Blackboard page on the left-hand panel. Let me see. Also, so this is the beginning of week 3, right? So basically our rhythm, we're doing pretty much one section a week, right? So we've done 1.1 and 1.2. So today we're going to be working on section 1.3 functions. And then what that means is next week, actually it'll probably be this Sunday. I think I said it for like this upcoming Sunday at 11 a.m. Exam 1 is going to become available. Now, in order to access exam 1, you have to pass the quizzes for weeks 1, 2, and 3. Right? I think you got to get like 4 out of the 5 questions correct, because the passing is 70, but it's like 4 questions. So it's 5 questions. So, you have to get 4 out of the 5 in order to access the exam. You don't want the exam to be available and then you can't access it because you didn't fulfill the prerequisites. Are there any questions for me? I saw the one about attendance. Did you guys have any other questions for me? So, as usual, feel free to unmute yourself or type in the chat. I do check the chat periodically, and I'll check attendance again for any. I think we have 1 person missing. Otherwise, we do have just about everybody in attendance. I'm only missing 1, but I'll check it again in another 6 minutes or so. And again, the design of the course, this is online remote asynchronous. So once you get your attendance credit, which everybody in the Zoom session right now has gotten theirs, you're not obligated to stay. This time is really, the real intent of this time is for it to be a Q&A or a study session, right? So I just kind of do a live version of the lecture notes just to kind of fill the dead air. Since we're kind of like on track or on schedule, what I've done in the past is like on the Mondays, I'll go to the lecture portion of it. And then on the Wednesdays, I'll do as many homework assignments as I can, right? And so that way you can kind of fill the 2 days and focus on that one section. But if you guys want to talk about any homework assignment, again, anything that's on Pearson, we can talk about it. Even when the exams become available, even when the exams are live, we can talk about it. Like, I don't want you to hesitate. If you have questions, you know, you can work on the exams during class. We can, if you have a question, we can pull it up and, you know, work on questions, because we can't get everybody. So we can get whoever asks. It's like a first come, first serve kind of basis. Those are almost free questions. I mean, sometimes we get them wrong, but that happens rarely. But yeah, so with that, let's go ahead and take some time. Let me just check the chat really quickly. So like if I go here, we got some chatting going on. Let's see what we got going in the chat. That's okay. That's okay. Cool. How do I get into the lab part? Yeah, so I think we answered the question about the lab. Again, when you log into our main landing page for Blackboard, when you open up Blackboard, and on the main page on the left-hand panel, there's a link that says Online Alex Lab. You click on the link, the contact info for the facilitator for that is there. And her name is Dr. Lamar. And basically whatever she says you need to do, that's what I expect you to do. And then I think at the midterm and the final, she's going to give me a grade for the lab portion for each person. I'm going to take those grades, scale it by 10%, you know, factored into your grade where it counts as 10% of your overall grade. Okay. So hopefully that answered that question. On that note, let's go ahead and get started and just hop into this material. So we're continuing chapter 1 of graphs and functions. I hope everyone had a great weekend also, by the way, right? Like, did anybody have any interesting stories they want to share? And I'll kind of just like one or two. Did I do anything interesting? Okay, so I ain't gonna lie, like most of the weekend I just game. Like I mostly play, it's only one game is like total cancer and it's totally toxic. But the interesting thing about it is I kind of fuse all the stuff I study into like bringing and breathing life in this game, right? So it's like I'll study like spirituality, mathematics, nature, rhythm and timing, martial arts, like all these different things, and it actually comes to life. Chess, like chess and war strategy, all this comes to life in this game that I play. The game that I'm referring to is Mobile Legends Bang Bang, and so it's like a 5-on-5 battle royale capture the flag style game. But I'm using like angling, positioning, baiting, rhythm, frequency, like in when I study my chart in the spiritual sense, it says that I'm an initiator. I have the power to initiate. And I've noticed that when I play the game, I get impatient. I'm like, yo, what are you afraid of? Just go, right? And so I'll intentionally start a fight and then run off just to get the ball moving. You know, so it's just really interesting. Anybody, if somebody have an interesting story from the weekend that they want to share, feel free to unmute and just share. But otherwise, you know, let's just hop into it. All right. So, or you can even type it in the chat and maybe we'll read it a little bit later. So graphs and functions. Okay, so chapter 1. So again, we're moving into section 1.3 functions. Some objectives with this section, we want to use functional notation and find function values. It's fairly light. Find the domain of a function, identify the graph of a function, get information about a function from its graph, and solve applied problems by using functions. Okay, so let's see what let's look at this definition. Can I get a volunteer to read this definition?
I can.
Okay.
A special relationship such as
who are we chatting with?
Cody.
Cody. Okay, Cody.
Yeah. A special relationship such as y equals 10x, in which to each element x in one set there corresponds a unique element y, in another set is called a function. Y is sometimes referred to as the dependent variable and x as the independent variable.
Okay. So can anybody like translate that into their own words, either based on this passage or based on your own experiences with functions? Like, what is a function? Like, either based on this or based on your experience in the past, what's a function to you?
Kind of like an equation where
Okay.
like the variables represent an imaginary number that could be any number.
Okay.
And you have those ratios to figure out, see, y is worth 10 of x.
Okay.
So you just have to figure out x. that you can figure out why.
Okay. So yeah, right. So like for me, a function is like you have a set of input values, which is like it's typically called the independent variable, which is usually our x, and we can choose those. We can just choose those, right? Like 1, 2, 3, whatever inputs we want, we choose them, and then we pass them through this equation or this function, and then the function is going to create a set of outputs that correspond to each input. So that's essentially what functions are, right? You have a set of inputs that pass through a function, and then the output, then it creates a set of outputs that correspond to each input, right? So y is sometimes referred to as the dependent variable, and x is the independent variable. So we have a set of inputs versus outputs. A function from a set x to a set y is a relation where each element of x corresponds to one and only one element of y. The set x is the domain of the function. The set of those elements of y that correspond or assigned to the elements of x is the range of the function, right? So if you think about all of your possible sets of inputs, we call that the domain of a function. And then once you take each of those input, pass it to the function, it generates a set of outputs. That set of outputs is what we call the range, right? So the collection of inputs is the domain, collection of outputs is the range. So then for each x in the domain of f, that corresponds a unique y in the range. The number y is denoted by f of x, read as f of x or f at x. We call f of x the value of f at the number x and say that f assigns the f of x value to x. Okay. Every y corresponds to exactly one x. Did I say that right? Let me go back. I think I got it backwards. In which each element of x corresponds to only one y, right? So for it to be a function, every x corresponds to exactly one y, right? You don't have one x that has two different y values. You'll see momentarily, a simple way to remember that, right? For right now, we'll leave it there. Every x corresponds to exactly one y in order for it to be a function. So functions can actually, do we talk about that here? We might not talk about that here, but we'll get to, there's some more I want to say there, but we're not there yet. Functions can be defined by ordered pairs, tables and graphs, and equations. So these are some of the different ways that we show functions. So in this example, we're asked to determine whether each relation defines a function, right? So we said that every x corresponds to exactly one y, right? So this is like a set of ordered pairs. So if we consider part A, do we have one x that corresponds to two different y's? Or in other words, do we have repeating x's? Just like in life, repeating x's might not be a good idea. Same thing here, right? It's a little bit different connotation, but if we look at part A, do we have any repeating x's? No,
Yes,
right?
the end one.
Yes. We do, yeah, we do, right? -1 goes to 2, and -1 also maps to -3. So if we were to plot those 2 points would be stacked on top of each other. That's an example of something that would fail the vertical line test, and so it's not a function, right? So that's an example where we have one x that corresponds to two different y's. That's not functional. Okay, what about part B? Do we have one x corresponding to more than one y?
No.
That one's no, right? Because each x corresponds to a different y. Okay, so we said part A was not a function and part B is a function. Okay, so the domain of part A are the set of inputs, so it's -1, 1, and 5, and the range are a set of outputs, which are 2, 3, and -3. Again, this is not a function because two of the ordered pairs have the same first component. In other words, we have repeating x's. This is not a function because that's just my simple way of one of my ways that I have remembering that is just because it sounds so silly. So that technique that I'm describing where I'm saying repeating x's is dysfunctional, that's a technique called the memory, I think it's like the memory mansion or the memory palace. Like if you just have this long list of things that you're trying to remember, you got to make like an acronym or something. You have each piece of information, each bit of information, you link it to a zany image. The zanier the image, the easier it is to remember. So for me, I just know from experiences, if you keep going back to your exes, a lot of times it just doesn't work out, right? For whatever reasons, y'all went y'all separate ways, so that's how I remember, that part here. You don't have to do that, but that is an actual memory technique. It's called the memory palace. But I have used it for some other things. graduate, like a lot of different things. But yeah, so we said no for part A, and then part B, we say yes, right? The domain, again, is just a set of inputs. The range, just a set of outputs. This relation is a function because no two order pairs have the same first component. In other words, no repeating x's, so it's functional. Okay, so determine whether y is a function of x for each equation. Let me think about this one. What's the simple way? Now, we could look at the graph. We haven't talked about this. So like, you know, we can plot the points, like choose several values of x, find the corresponding y. Let me see. If we were to, can we solve for x in the first one? Let me see. It looks like we can solve for x in the first one, right? Let's see. Can we solve for x in the first one? Let's just try. So suppose we tried to solve for x in part A, right? So we have this 6x squared minus x. You don't have to write this. I'm just kind of exploring. Let's set this equal to 0. So actually, would that work here? Because I don't know that it's going to make it any easier. That might be going astray, but because I'm still trying to limit it to things that we've talked about. I think the simple thing here is just choose some values of x, find the corresponding y. Just a little bit of foresight or foreshadowing, I think is the word I was looking for. So the highest, I know that this is a U-shaped curve, right? It's a parabola. The highest degree is at 2, right? We're going to talk about this at some point. Right now, just kind of using it. You can, now if you had your like Texas Instrument, like a TI-83 Plus, you can look at the graph there. You can also use GeoGebra to just look at the graph. You can make a table of points, choose the x values, find the corresponding y's, plot the points, right? We're just looking at the graph, but this should be a U-shaped graph. It opens up to the right. It's a U-shaped graph that opens upward, and the y-intercept is -12, right? So if after plotting, if we had some image that looked something like this, right? Just something that has this shape. Again, we can choose values of x, find the corresponding y's, plot the points, or we could plot it in the graphing utility, or we can also use like geogebra.com, which is free online graphing. But if we got an image that looked like this, notice no matter what x value you choose, they all correspond to exactly one y. You don't have like, these are all, this is what's called passing the vertical line test. So no matter where you put the vertical line, it will touch the graph once, right? And let's change this one to like, change that to blue and this to green. So the blue part is our graph and the green, and actually let's do this. So, no matter, that's called the vertical line test. That's one of the ways that we have for showing whether a graph is a function, passing the vertical line test. So that, and we'll see an example where it fails the vertical line test, right? Let me see. I feel like something's missing from there. Because if we do that, that's going to introduce fractions, and that's not going to make it any better. And I don't remember it being like that, but this is fun. Now, okay, so in the second one, let's do this. Now, notice we have this y squared, which is kind of weird, right? Let's solve for y in this one. So, if we start with y squared minus x squared equals 4, right? And let's say we're going to solve for y. So we add x squared to both sides. That'll give us y squared equals x squared plus 4. And then we take the square root on both sides, right? So if we're going to get the y by itself, can somebody tell me what symbol do we need to include whenever we take the square root? What do we need to include whenever we take the square root?
Plus or minus.
Plus or minus, right? So what this means, what ends up happening when we take the square root to solve for y, we get this plus or minus, and that plus or minus is what causes this to fall apart, right? So then ultimately we get y equals plus or minus the square root of x squared plus 4, right? Let's see. Let's see, we did 1, 2, 3. 4, 20. I'm trying to get some clean numbers, but I don't think I can get anything clean. So like, for instance, notice when x is 1. If we let x be 1 in this case, then we get what? Y equals plus or minus the square root of 5, right? When x is 1, we get 2 outputs. So this is an example of something that would fail the vertical line test because we have one x that corresponds to 2 different y's, so this is not a function. So then part A, we said, yes, it's a function. Yes, a function. But then part B, we said it's not a function, right? Not a function. Right? And part B, we said it's not a function because we can find one x that corresponds to more than one y. Okay, so that's just us talking about it. Let's see what the prepared notes are saying. Yeah, let me finish this one out, then I'll go back and check for any stragglers. So for part A, what the prepared notes did, let me see. Oh, see, I knew something was off. I knew something was off with part A. Because I was like, part A looks weird. And I was like, I don't remember it being like that. So the error, there was a typo with part A. I mean, you know, what we have is fine, but here it is right here. For some reason, this printed like that as negative x. It was supposed to be a negative 3y. So let's actually go back and work that one with that edit. So let me just want to create some space. So that was a negative 3y, right? I knew something was off there. So this was supposed to be minus 3y. Minus 3y. Okay, so let's do it with that edit. So then suppose we have 6x squared minus 3y equals 12, right? So yeah, now if we were to solve for y, right? If we were to solve for y here, let's solve for y and see what happens. So if we're going to solve for y, we can add the 3y and subtract 12. And so ultimately we'll get something like 3y equals 6x squared plus 12, right? And then if we're going to solve for y, we can divide each term by 3, right? And so if we divide each term by 3, we get, what is that? 2x squared plus 4, right? Okay, now, fortunately, what happens is we get y equals, again, we still get a degree 2 polynomial, which means we have a U-shaped curve. The leading coefficient is positive, so that means this curve opens up. So we just have a U-shaped curve that opens up with a y-intercept of 4. Now, we don't know where that vertex is. I mean, we could find it. But for our purposes, this just means that we have a U-shaped graph, right? Again, you can choose several values of x, plot the corresponding y. You'll notice that you won't be able to find one x that corresponds to more than one y, right? So you'll get a graph similar to the one on the left. It's just that the vertex might be moved around. Instead of it might not drop below the I don't think it's going to go below the x-axis, but it's still going to be a function, right? Okay, so we made that augmentation. So let's see what the notes did, right? So they solve for y, 2x squared minus 4. One value of y corresponds to each value of x. So it defines y as a function of x, right? So you can't, in other words, you can't find one x that corresponds to multiple y's, like what happened for us in the second one. If we look at the second one, when we solve for y, notice we got that plus or minus, right? So that plus or minus, 2 values of y correspond to each value of x, so y is not a function of x, right? I know that's a little bit back and forth. I don't want you to get too bogged down into it, right? To me, that explanation is like the hardest part of this. Once you start getting into like crunching numbers and working through equations and stuff like that, it becomes second nature. So try not to get too bogged down into like the introduction to it. It gets much lighter. Let me pause for the cause right there. Let's hop over and just check and see. I think, okay, everybody's here that's going to be here, I think. And then let's check the chat real quick. Weekend homework. Yeah. Oh, yeah. Yeah. Also with the homework, I do encourage you all, there's a few things there. So with the homework, I do encourage you to like work together. I don't know if this class has a group me or not, but I know students in the past have done group me. I encourage it. I think it's a good idea. I think it more closely resembles life when you get out, collaboration. So that's one thing. Another thing, I encourage you to like, you can take this and sit down with the tutors if you're stuck. If you have momentum and you're able to, move with minimal support, then you want to go as far as you can with the least amount of support as possible. But then it's okay if you wanted to take this stuff and sit down with the tutors and work on it. And as long as you're getting the stuff submitted, that's the main thing. And then there was something else in the chat. I completed some French work and I learned some new choreography. Oh, you got to show me some dance moves. Now, it's not true that every Black person can dance. Now, I can feel it, but the only reason I can't dance is because I don't ever practice. Whatever we practice, we get really good at. I complain a lot, so I'm good at complaining. Try to work, get rid of that one. And I game a lot. I'm good at gaming and getting mad and getting frustrated because I solo all the time. But I know that if I practice at dancing, I know I would be good at it. I know that anything that I practice at, I would be good at, right? And that applies for everybody. Whatever we practice, we'll get really, really good at, right? So, not that you got to be a math genius or anything, but if you want to be good at math, I mean, in all honesty, when I was a student in math, which I still am, but when I was learning about it, I mean, honestly, it was at least like 3 or 4 hours every day. Like at least 5 days a week. But the way I did it though, when I was a student at Morehouse, I did work study. I intentionally chose work study where I was sitting at a desk. I was sitting at this desk. I was getting paid to sit with, let's back up. I was at Morehouse on scholarship, so that was one check. And then I was like, I found some work study where I worked in Archer Hall for like 3 years. But I intentionally chose that position because they were paying me to sit there for hours on end at a desk, just pretty much just sitting there. So I was like, okay, you know what? If I'm gonna get paid to sit at this desk, that's when I'm gonna do my homework. So I got double paid to do my homework. And then once I got off of work, I went on and did whatever I wanted to do. I gamed or hung out with people. I did whatever, right? But that was my plan. That was my way. I was like, okay, if I have to sit here, that's the perfect time for me to go ahead and get this stuff done. It just didn't make sense to sit there for hours and then go home, sit more hours trying to work. And then also I found that doing, especially mathematics, when I first wake up, first thing in the morning, like a lot of times I've accepted my night owlism. I don't know. I just made that word up, but I'm definitely a night owl. And so that's when I got most of my work done. I would wake up at like 2 and 3 in the morning. And I mean, I would just be going in hard. Like, we're going through everything. That's my favorite time to kind of get through stuff because it's so quiet. It's minimal distractions. I'm not really disturbing people. And then like I stayed in the dorms, the suites, the apartments. And so there were like study rooms everywhere and I can access them like 24/7. It was really nice. I really enjoyed it. I actually kind of miss it, but it's okay. I kind of recreated it on my own, but now I mostly like game. Sometimes I'll meditate and stuff like that. Okay, let me see the time. We're good on time. We got a solid 10 minutes. Let's look at this example. So let G be the function defined by this equation. Evaluate each function, right? I feel like there's nothing too terribly interesting going on here. I don't think I'm gonna write this one out. I'm just gonna kind of talk through this one. So evaluating a function, basically this is just saying, evaluate G when X is 3, right? So when X is 3, basically you replace each X with 3 and get an answer. So when the input is 3, what's the output, right? Now for these first 3, you can do these by hand. You would say 3 squared is 9, minus 6 times 3, right? Plus 8. So then that's what, 9? 6 times 3 is minus 18 plus 8. I think that one's like -1, right? Right. So, I mean, and there's nothing wrong. Like with plugging it in, that takes practice. Just make sure that you can do it. I kind of want to do a demo. Let me see if I can get this to come up. My device isn't being too temperamental. Like board, that's fine. Let's go like this. And I'm looking for this one. There we go. Looking good. Reload and refresh. Okay. So I just wanted to do a demo on like some of the capabilities of a TI-83 Plus, right? So again, we could go through and do each of these by hand. It's encouraged. It builds, mental strength and savviness and things of that nature. I just want to show you what's possible, at least with the first three examples, the first three parts. So if I go to my y equals in the upper left-hand corner, and I can type in the function. I have my x squared minus 6x plus 8, right? Okay, I'm going to quit. So I'm going to hit second mode to go back to the home screen. And I want to evaluate each of these. So on the far right-hand side, kind of in the middle, it says clear. To the left of that, the clear button is a button that says VARS, variable. To me, I think it stands for variables. I'm gonna click on VARS. And then if I go to the right, it says Y variables or Y vars. I think it's variables. So I'll go to the right. I click on number 1 for function. I click on number 1 to call on the function that I just typed in. So I'm gonna click 1 again. I'm gonna do an open parentheses. And so that says G of 3, I'm gonna put parentheses 3 like this. So where they have G of 3 on the calculator, on this calculator, it's gonna appear as Y1 of 3. And then, so I think we got an answer of -1, and you see it there. And then I'm gonna hit second enter to call on what I just typed in. And now instead of doing 3, I'm gonna do -2. Let me see, that's gonna be 4 plus 12 is 16, 24, right? I think we should get 24. Boom. Let me just go ahead and do the third one. All right, 1/2, right? Knowledge is power, and I'm gonna hit math. Now this is a decimal, we can also hit as a fraction. It might be possible to do it as a mixed number. Well, it's 5 and a quarter, right? Because of the decimal. So, we saw ways where we can evaluate this in the calculator. And then for the other part, we would have to do that by hand, right? So we'd have to replace each x with a plus 2, expand it out, and then simplify. And then the same thing for part E. But I did want to do that demo showing you that, you can at least evaluate functions in a Texas Instrument calculator. And there are other ways to do it digitally as well, but, So you see the first 3 parts there written out, okay? And then I'm just going to rely on this. Notice they expanded, right? So this expanded into these guys. Then they distributed this -6 right here, right? And then combined like terms, and they finished here. And it's something similar for here, right? It's just that nothing canceled out, right? Now this technique, this one is like a precursor to something that's coming up, okay? And again, if anything is not clear, you have to stop me to get my attention. Either type in the chat or just unmute yourself and say, "Hey, can we go back?" or anything like that. Okay, let me see. A solid, just under 10 minutes. Let's keep going. So we have this agreement on the domain. If the domain of a function that is defined by an equation is not explicitly specified, then we take the domain of the function to be the largest set of real numbers that results in real numbers as output. All right. Right. So unless the domain is specified, we're going to be working with the domain that produces the largest set of real numbers. We're not going to be. We don't really want to consider numbers that's going to produce imaginary or non-real solutions, right? For right now, unless the domain is specified. So in these examples, we're asked to find the domain of each function, right? Let's see. Okay, so there are mainly two main things going on here, two different types that are at play. So with this part A, this is like a rational function, right? It's like a fraction. So in general, for these rational functions, the domain is going to be all reals. And by domain, we mean the set of inputs, right? In general, for rational functions, the domain is all reals, except, what do you think we have to get rid of? When we're working with fractions, what do we have to be on the lookout for? What can we not do with fractions?
Divide.
Divide by.
Can't divide by a fraction.
Close. We cannot divide by
X.
No, we can divide by X. What number cannot go in the denominator?
1.
Oh, we cannot divide by 0. Okay. So let me share this then with that. I'm glad we did that exercise. So say, let me see. So say we have some number divided by 0, right? This is what we were just talking about. So we cannot divide by 0 when it comes to fractions. This is a KO. You want to knock that out. So this is undefined, right? Undefined. I don't know. Right, so we cannot divide by 0. But if we have 0 divided by some number, this is okay. This is okay. This is going to be equal to 0. Okay. So if we divide by 0, that's a KO. So in some number divided by 0, that's a KO. That's undefined. We can't divide by 0. But 0 divided by some number, that's okay. So that's going to be equal to 0, right? So I'm glad we did that exercise. So in general, okay, so when it comes to rational function, the domain is going to be all reals except any x that makes the denominator 0 because we cannot divide by 0, all right? Because we can't divide by 0, we got to throw out any x that makes the denominator 0, all right? Let me see. So can you tell me either tell me the result, what value of x makes the denominator 0, or can you devise a plan to find that value of x that makes the denominator 0? So for part A, if we want to know what value of x makes the denominator 0, then it's probably a good idea to set the denominator equal to 0 and solve, right? If we want to know what value of x makes it 0, set it to 0 and solve. So if we say 1 minus x squared equals 0, right? I'm going to add the x on both sides. And so we'll get something like this. Take the square root. What did we just say a moment ago? Whenever we take square root, we need to do what again?
Add a plus
Plus
or minus.
Plus or minus, right? So when we take the square root on both sides, we got to do plus or minus. So then what this is saying, I'm a little bit out of space. I'm just going to, here. So then x equals plus or minus 1. So what we're saying is that when x is either positive 1 or negative 1, they make 0 in the denominator. And so that's outside of our domain because we cannot divide by 0. Hopefully that was okay. All right. So for part A, we have to throw out plus or minus 1. Actually, let's go like this. Wait, what happened there? Oh, that's a 1. Okay. Right. So for part A, and I see the time, we're going to wrap this one up. This is going to be it. X is not equal to plus or minus 1. So if we were writing that solution in interval notation, we want to capture every number on the number line except plus or minus 1. We're going to see how to do that in just a moment. All right. So again, to recap this part A, the domain in general is going to be all reals except any x that makes the denominator 0 because we cannot divide by 0. Okay. For part B, so similar to part A where we can't divide by 0, when it comes to square root, we cannot take the square root of what kind of numbers? What kind of numbers can we not take the square root of?
Negative number.
There it is. So we cannot take the square root of negative numbers, right? Square root of 0 is 0. Square root of 1 is 1. 4 is the easy one. Square root of 4 is 2. Square root of 9 is 3, right? So these are positive numbers, right? Or non-negative numbers. But if we try to do the square root of negative 1, we can't find a number that multiplies by itself to give us a negative. Because positive times positive is positive. Negative times negative is positive, right? So we don't have any real numbers that multiply by themselves to give us a negative result, right? Long story short, we cannot take the square root of negative numbers. So in general, for part B, I'll just put it here. Since the domain, let me see. So because we cannot take the square root of negative numbers, that means our domain is going to be, x has to be greater than or equal to 0, right? So if we're talking about x is greater than or equal to 0, so that means like in interval notation, we would start at 0, the far right will be infinity. Okay, riddle me this. If I put a bar below my inequality, can you tell me what kind of grouping symbol the 0 gets? So the bar means that we can be equal to it. So bar means we get a bracket. Bar means bracket, right?
Less than or equal to.
Greater than or equal to, right? Because the domain or the set of inputs, the ones that can make it true, we're throwing out the ones that are less than 0, so we're keeping the things greater than or equal to 0. What symbol does infinity always gets in this context? Infinity always gets parentheses, right? Parentheses typically means we get really close to that number, but we never reach it. In the context of infinity, we just never reach infinity. It keeps going. But if a number had a parentheses, we get infinitesimally close to it. We get really, 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 really close to it, but we don't include that number itself, right? That's if the parentheses was next to a number. Okay. So then for like part C, we will basically be putting those two concepts together. Not only can we not divide by 0, but we also cannot take the square root of negatives, right? So if you put the concept for part A with the concept for part B, then like if you just consider the square root, normally it would be x is greater than or equal to 0. But because we can't divide by 0, that means it cannot be equal to 0. So then we would say this has to be strictly greater than 0. Okay, so I'm going to rely on my prepared notes because we are out of time. I know that's a little bit of a mouthful. And then for part D, that radicand, which is the inside part, again, has to be greater than or equal to 0. Okay, so let's look at part A. So again, we cannot divide by 0, so we need to find out what values of x make the denominator 0, namely plus or minus 1. And so if we wanted to capture all numbers on the number line except plus or minus 1, this is how we would express it in interval notation, right? So the far left, we can choose any number going all the way to the far left of negative infinity, up to -1, and then we can choose any number between -1 and 1, and then any number to the right of 1, going off to positive infinity. Parentheses means we get really, really close to -1, but we don't include -1. Parentheses mean we get really, really close to 1, but we don't include 1. And then union just means, this is called union. It just means the solution set is going to be this combined with this combined with this. So union just means you're basically considering all of these together. Okay, so that was part A. Okay, so the square root of a negative number is not a real number. So then the domain is going to be the set of all x such that x is greater than or equal to 0. And the interval notation is going to look like this, with the square bracket on 0. All right, let me do these last two. So if we put the two together, the square root of a negative number is not a real number. So normally, if we just consider the bottom by itself, this radicand, this x minus 1, will be greater than or equal to 0. But because it's in the denominator, it can't be equal to 0. So then we have to lose the bar, and then so you have x minus 1 is strictly greater than 0. And then when you solve it, you get this. Okay, just do the best you can with it. And then the domain here again, we can't take the square root of negative numbers. So what we would have to do, we would have to say this radicand, this inside part, needs to be greater than or equal to 0. Let me think about it. That one is actually. Let me think. Okay. Can you factor it? Let me think. Does that factor? I think it does, all right? A positive 3 and a negative 1. Okay. I'll try to be as quick as I can with this one. So we're considering, when is this U-shaped graph greater than or equal to 0? In other words, when is the parabola above the x-axis? This is a U-shaped curve. When is it above the x-axis? So then you're going to find your intercepts by factoring, and you're going to get a positive 3 and a negative 1. Did I say that right? Well, when you solve it, it'll be -3 and positive 1. You kind of need to create test intervals there. We're gonna put a pin in this, and we'll revisit this because this will pop up again like this thing that I'm describing here, we're just out of time. It's going to pop up again in some other examples, and we'll discuss it again in the future. Let me take a moment. I know there was somebody that needed a request. I think it was about attendance from last week. Other than the attendance question, did anybody else have any questions? If there aren't burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day.
Thank you. Have a nice day.
Thank you.
Thank you.
Yep. I'm pulling up the attendance from last week for the student. What's today?
Professor, how would I go about checking the lab? I mean, doing the lab, like getting to the lab?
Say that again. I'm sorry. I got knocked offline.
You're good. How would I go about getting to the lab again for the lab I'm talking for this class?
So the lab is located on Blackboard on the left-hand panel. There's a link that says Online Alex Lab. You click on that link and contact the instructor for that.
Okay, all right.
Okay, let me see. Let me check the chat one more time because I know. Oh, it's gone now. Is a student here that had a question about attendance?
Yes, sir. I'm still here.
Yeah. So when I check my records, it shows that you were here.
Okay. Thank you. Have a good one.
You as well. Any other questions, gentlemen? Let me check the chat. I think the chat is clear. Okay. So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.
Thank you, Professor. You too.
Yep.